Hi guys, today we are going to be talking about polynomial functions. We are going to look at the degree, leading coefficient, constant term. We are going to be asked to find the zeros of partially factored functions, and then to wrap it up, we will be given the zeros of a function and we will be asked to write the corresponding function. So we have a lot of cool definitions, but I'd rather talk to you than read to you. So let's do this. So a polynomial, what is that? A polynomial could be one term or sum of many terms. The catch is that we need whole number exponents on the variable. So we have variable terms. Let's go ahead verify that all the exponents on the let's go ahead verify that all the exponents on the variable terms are whole numbers. So 1 and 2 are whole numbers, so we're good. Now, what is the degree? You can read or I can speak to you. Let's do this. So the degree of a polynomial is code for the biggest exponent on any of the variable terms. For this problem, the biggest exponent on any of the variable terms is 2. So for that reason, the degree is 2. Okay. Now, what is the leading coefficient? The straight definition is the leading coefficient is the coefficient of the first term if the polynomial is written in descending order, meaning from highest power to lowest power. But the polynomial doesn't really have to be written in descending order. You identify the degree of the entire polynomial, which is 2. I'm going to circle that degree 2 term. Whatever the coefficient of the degree 2 term is, that will be the leading coefficient. So in this case, it's 4. Constant term is just a fancy way to say number. Okay, so that loose number is 5. So the constant term is 5. So we have zeros or roots. So it says a number r is said to be a zero or root of a function of a function p of x if p of r equals 0. Okay, whatever that means. Okay, so I'm going to try to explain it to you in a bit. Okay, so we have fun problem. Identify the degree of the polynomial and find all zeros. Okay, so for the polynomial that we just knocked out, it was a little bit less intense for me to identify the degree. Degree, code for biggest exponent on any of the variable terms. But what I want to point out is the difference between the first one and the second one. Right here we do have a sum of terms. Right here we have a product of terms. So it's not as straightforward for me to say, bam, this is the biggest exponent. Okay, so we have some options. We can FOIL it out and then see what the biggest exponent is, but we have no time for that. So what we can do, we can just add up the exponent because we're multiplying. So like the degree of this first binomial, this first factor is 1. So I'm just gonna say degree equals 1, and then we're gonna add to it the biggest exponent in the next factor, which is also 1. And then that sum will give us 2. Okay, so in this case it was not as straightforward as just identifying the biggest exponent. Why not? Because right here we have a multiplication problem, not a sum of terms. But if you don't trust me, then go ahead, FOIL it out, and then you can confirm that the degree or the biggest exponent on any of the variable terms is 2. Let's go ahead, put this in the right place. Now, what are the zeros? The zeros of the function are the values that will make the function a 0, and I'll come back to this. Okay, so if you want to know what makes this a 0, then you're going to have to take the polynomial and set that equal to 0. So let's do this. Let's go ahead, take the polynomial, set that equal to 0. So right now we have that a product equals 0. If a product equals 0, then there's no way around it. When we apply the zero factor property, one of these factors has to equal 0. So either the first factor equals 0 or the second factor equals 0. So if the first factor equals 0, after we add 3 to both sides, that will give us x equals 3. If the second factor equals 0, after we subtract 5 from both sides, that will give us negative 5. So the moral of this story is that the zeros, I don't know why I put a colon and an equal sign. The moral of the story is that the zeros are 3 and negative 5. The question is, why do we call them zeros? We call them zeros because these are the values that will make the polynomial a 0. Okay, so when x equals 3, we have 3 minus 3 is 0. 0 times something is 0. So the value of the function at 3 is 0. So this is what the statement above says before. So if we have some number, and if that number is really a 0, then when we evaluate the function at whatever that number is, the value of the function should give us 0. Okay, I'm not sure if I conveyed what I wanted to say, but I tried. Okay, so let's go ahead and almost wrap this up with this almost last problem. Okay, so a fun problem reads, it says, where am I? So it says list all zeros, real and imaginary, of the polynomial function and specify those zeros that are x-intercepts. And I know that you have a graphing calculator, but I need you to answer algebraically, so don't just punch it in. So long story short, the question says find the zeros. Okay, so if we want to find the zeros, we want to know what makes it a 0. If we want to know what makes the polynomial a 0, then let's go ahead, take the polynomial and set that equal to 0. So let's go ahead, take the polynomial. Give me a sec. Gonna take me a while, but don't worry, we'll do it. So let's go ahead, take the polynomial and set that equal to 0. So I'm not gonna lie, this is a pretty brutal problem, but the one thing that I am thankful for is it's already kind of factored. Okay, so we could break this down more and maybe this trinomial too, but it's already kind of factored. So at this point, let's apply the zero factor property. So again, the zero factor property states that if a product equals 0, then one of these factors has to equal 0. So it's going to take us a little while, but let's do this. So either the first, second, third, or fourth factor equals 0. Okay, so either the first factor equals 0, or the second factor equals 0, or the third factor equals 0, or the fourth factor equals 0. Fantastic. Okay, so let's go ahead and do this. So if the first factor equals 0, let's go ahead, I solve for x. Go ahead, subtract 5 from both sides, and that will give us x equals -5. If the second factor equals 0, you can solve this however you like. We can use the square root method. So if we isolate the squared part, we're going to go ahead, add 4 to both sides, and that will leave us with x squared equals 4. To undo the square, let's go ahead, square root. And after we square root, don't forget your plus or minus. That will give you that x equals positive or negative, whatever the square root of 4 simplifies to, which in this case is 2. So I make it very clear that your answer should not be submitted with the plus or minus, but we're gonna write the solutions in the space provided. So that's how I'm gonna leave it with the plus or minus. Okay, next equation. This is not a degree 2 equation, so I can't use the square root method, but I believe I can factor this. So binomial minus, so I want to ask myself, do I have a difference of squares? So remember from back in the day, if we have a difference of squares of the form a squared minus b squared, then that will always factor to a plus b times its conjugate, or a minus b. For me, it's really difficult to eyeball like yes or no, we do have a difference of squares, so I'm going to do what I call the mold, M-O-L-D, okay? So do I really have something squared minus something squared? If I do, then we attack it, and if we don't, then we got to find another technique. Now, x to the fourth is a perfect square because that's the square of x squared. Cool. All right, how did I get that? Because I'm cool like that. But no, what I did, I used the power rule in reverse. We take the current exponent divided by the desired exponent. So in this case, 4 divided by 2. If it gives us an integer, then it's gonna fit our bill. Okay. So 1 is a perfect square because it's the square of what? So to answer the question, are we subtracting 2 squared terms? We sure are. So if this is our question, then this is what it's going to factor to, a plus b times a minus b. So in this case, our first base is x squared, and the second base is b. Okay, so again, if this is our question, this is our answer. So this will factor to x squared plus 1 multiplied by x squared minus 1 equals 0. Okay, so we can factor more if desired, or you can stop here. It's a personal choice. I'm gonna factor all the way. Okay, this binomial plus, the only way we can factor it is if we have a sum of cubes, because a sum of squares is not factorable. But x squared is not a perfect cube, so we're good. Binomial minus, do we have a difference of squares? Yeah, we sure do. I know you see it, but I don't. So I'm gonna do the same, say the same speech. I want to know, do I fit this mold, the difference of squares mold? And the answer is yes. Why? The reason is because x squared is a perfect square because it's the square of x. 1 is a perfect square because it's the square of 1. So this will factor to x plus 1 times x minus 1, and don't forget the binomial factor before it. Fantastic. We got an equal sign, 0. Alright, so we factor this. Let's go ahead and apply the zero factor property. So if a product equals 0, then one of these factors has to equal 0. Either the first, second, or third factor equals 0. So if the first factor equals 0, let's go ahead and solve it by using the square root method. We isolate the squared part, and when we do, after we subtract 1 from both sides, that will give us x squared equals square root of negative 1. Take your time. Go ahead, get rid of the square. To undo the square, we're going to go ahead square root. Don't forget to insert your plus or minus, and that will leave us with x equals positive or negative, whatever the square root of negative 1 simplifies to, but that's actually the imaginary unit I. How about that? Okay, so we have two more zeros, positive I and negative I. If the next factor equals 0, then that's going to lead to a 0 of negative 1. And if the third factor equals 0, then that's going to lead to a 0 of positive 1. So far, our zeros are negative 5, positive 2, negative 2, positive I, negative 1, positive 1. Cool. Okay, final factor. Okay, so we have this equation equals 0. Is this factorable? Answer is no. There are no integer factors of 7 that add up to negative 5. So we're gonna go ahead, go straight to quadratic formula. So we have x equals opposite b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And if you missed my singing, I figured you didn't really miss it, so that's why no more singing. So for my peace of mind, let's go ahead and identify the values for a, b, and c. The leading coefficient is 1, so that's our a. Coefficient of the x term is negative 5, that's our b. Constant term is 7, so that's our c. Okay, we have the formula nailed. We have a, b, c identified. There's nothing stopping us. So that will give us x equals opposite b. Value of b is negative 5. So we should have negative 5. Then we're going to add or subtract the square root of b squared. Value of b is negative 5. Please wrap it up. With parentheses, this will simplify to positive 25. And without the parentheses, it will simplify to negative 25. So careful. Let's keep going forward. Where am I? Minus 4 times a is 1, c is 7. Okay, so the toughest thing about solving a quadratic equation by using the quadratic formula is remembering the formula itself. The next toughest part is just careful with your arithmetic. Okay, alright, so the denominator should be 2a. Value of a is 1. Cool, we did it. So quadratic formula is okay, you know, it's heavy computation, but we got this. Opposite of negative 5 is positive 5. And then we're going to add or subtract the square root of whatever the radicand simplifies to. I'm running out of space. I'm going to punch it in with my calculator. And when we do, that gives us negative 3. Cool. And that's all over 2. Okay, cool. Alright, let's keep going. So we're square rooting a negative number, and that will give us a non-real number. When we simplify the square root of negative 3, we're going to replace the square root of negative 1 with the imaginary unit I, and then we're going to multiply it by the leftover radical, which is square root of 3. Okay, so far we have 5 plus or minus I square root of 3. If part of our answer is not a real number, then the entire answer is not a real number. Let's go ahead and separate the real part from the pure imaginary part. So that will give us, the first term is 5. Then we have a fraction bar, so let's divide it by 2. Then we're going to add or subtract the second term. and divided by 2. Okay, so let's go ahead, get our credit. Okay, let's go ahead, list it. The degree, did they ask us that question? I think I forgot to delete it. Okay. Yeah, yeah, I think I cut and paste and I forgot to delete something or change something. Okay, so what are the zeros? So the zeros are -5, +2, and -2. Then we have a positive I and a negative I, followed by a -1 and a +1, followed by, let's go ahead, write it. So we have 5/2 plus I square root of 3/2, and then 5/2 minus I square root of 3/2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Cool. All right. So now, what are the x-intercepts? Okay, coming to the top, it says the x-intercepts are the real zeros. Okay, the real zeros are anything that doesn't have an I. Okay, the x-intercepts of the polynomial will be -5, 2, -2. I is not a real number. Like we wouldn't see I in the xy plane. Okay, so the x-intercepts are only the real zeros. So no I, no -I, but -1 and 1, those are real numbers. So if we had the time to punch it into our calculator, we would have seen that the zeros are the x-intercepts, and I believe that's it. Cool. All right. So again, we were going to do a total of 2 sets of problems. One of the objectives was to find the zeros of a polynomial. Now in the next problem, which is the final problem, I'm going to give you the zeros, and then I'm going to ask you to tell me from what polynomial did they come from. Cool, found it. So it says, find the polynomial of least degree with integer coefficients that has the given zeros. Write your answer in A factored form and in B general form. So we have that the zeros are 5/2, -1, and 0. Let's go ahead, write it out, but separately. So we have x equals 5/2, x equals -1, and then x equals 0. Kind of like when we were finding the zeros and we're applying the zero factor property. We had said, like, if a product equals 0, then one of these factors has to equal 0. So that's pretty much what we're doing. So we're splitting them up, and then we'll just equate them to 0 one at a time. So because we want integer coefficients, we don't want these fractions here. So let's go ahead and multiply both sides by 2. So when we do, after we multiply both sides by 2, that will give us 2x is equal to 5. Cool. Let's go ahead and set this equation equal to 0. So we subtract 5 from both sides, and that will give us 2x minus 5 is equal to 0. So if -1 is a 0, what will be the corresponding factor? Let's go ahead and set it equal to 0. So we add 1 to both sides, and that will give us x plus 1 equals 0. Third factor, we have third 0. If x equals 0, what would be the corresponding factor? Well, that's kind of like a trick question, because it's already set equal to 0. So if you subtract 0 from both sides, you're still gonna get x equals 0. So for the polynomial, how should we name it? Should we use p of x, or oh yeah, you cannot see that. Should we use p of x or f of x? To tell the truth, it doesn't really care. You could call it z of x. It doesn't specify what to name it. Our book will call it p of x just for polynomial. But if you're like, nah, me and f of x write all day, then go ahead, call f of x. Okay, so let's go ahead and put p of x. So if these were the zeros, what is the polynomial that they came from? The polynomial that they came from is going to come from the product of these expressions. So it's going to come from the product of 2x minus 5, x plus 1, and x. So that'll be the answer to A. Okay, write the polynomial, leave it in factored form, and then write it in general form. So that's when we multiply. Let's go ahead, take our answer, and then we're going to expand all factors or multiply. So let's go ahead, group the first two binomial factors. We'll FOIL it out and then distribute the x. Product of the first terms will give us 2x squared. Product of the outer terms will give us 2x. Product of the inner terms gives us negative 5x. Product of the last terms will give us negative 5. Take your time, bring down the rest of the problem. Don't rush yourself. When we combine the like terms, we only have one squared term. The sum of the middle terms, namely 2x and negative 5x, will give us negative 3x. We bring down the rest of the problem. Take your time, you got this. Ooh. Let's go ahead, distribute the x. Product of x and 2x squared will give us 2x cubed. Product of x and negative 3x will give us negative 3x squared. Product of x and negative 5 will give us negative 5x. Cool. So we have answered this question. The question says this: if these are the zeros, what will be the corresponding polynomial? And these would be the corresponding polynomial. One of the polynomials is written in factored form with integer coefficients, and the other one is in expanded form or in general form. You did it, guys. Thank you.